Okay, so this is, so I'm going to take you through some passages from a book called Divergent Series.
Okay.
What do you think divergent means?
Different.
Diverge.
Diverge. Split.
Yeah, what's the opposite of diverge?
Converge.
Converge. Okay, so for when we're talking about infinite series, people like to either say a series converges, and a good example is like the 1 plus a half plus a third, or plus a fourth plus an eighth
Converges
series.
to 2.
Yeah, it keeps getting closer and closer to 2. Or a divergent series means, maybe a very simple way of thinking about that is, it doesn't seem to be getting closer and closer to anything. So 1 plus 1 minus 1 plus 1 minus 1 is an example of one that's not getting closer to anything. And also, so is the one we looked at, 9 plus 90 plus 900 plus 9,000. That doesn't seem to be getting closer to anything. And the one you originally asked about, 1 plus a half plus a third, or sorry, 1 plus 2 plus 3 plus 4, also doesn't seem to be getting close to anything. So this book is about all those kinds of series. So one of the first things the author, G.H. Hardy, who was a friend of Ramanujan, is plain that the first step towards such an interpretation must be some definition or definitions of the sum of an infinite series. So we need to define what we mean by a sum of an infinite series. It's not just saying this is this. He's saying, what are we talking about when we say that? This remark is trivial now. It does not occur to a modern mathematician that a collection of mathematical symbols should have a meaning until one has been assigned to it by definition. So we're playing a little bit fast and loose with the definition of sums and also the definition of equals when we're talking about these series. So in some ways, the 9 plus 90 plus 900 plus 9,000 series does seem to sum up to infinity. So in some ways, we might want to say that sum seems to be infinity, right?
Yeah.
But in other ways, we might want to say that sum seems to be what?
Minus 1.
Minus 1. So maybe we're talking about two different things there, two different definitions of equals, or two different definitions of what does a sum mean. So these are words that you didn't think were imprecise. But we're seeing examples where we start having slightly strange results. Oops, going the wrong way here. I want to get out of this. And I want to take you to the next one. So, but it is broadly true to say that mathematicians before Cauchy, this is a famous French mathematician, asked not how shall we define 1 minus 1 plus 1 minus 1, but what is 1 minus 1 plus 1 minus 1. So mathematicians have resolved these problems about these series by saying how should we define what this series is, rather than what is the sum. The sum, turns out this question doesn't even really have a good meaning. Strange, huh?
Yeah.
So we're going to define 1 plus minus 1, 1 minus 1 plus 1 minus 1 to mean something. So it's interesting. So you can see further down here on the screen, hopefully you can see my mouse, but it says the sum is a half, or S is a half for the series.
So we kind of defined it.
We're defining it to equal a half
Yeah.
in some ways, which is kind of neat. But then we'll go on further in the book. Hopefully the browser didn't freeze here. There we go. Go further in the book, and look what we have here. 1 plus 1 plus 1 plus 1 plus 1 equals?
Minus
a half.
Minus a half. 1 plus 2 plus 3 all the way out to infinity equals?
Minus 1/12.
So what do you think's happening there?
Did they define it?
Yeah, they're looking at a different system of arithmetic, or a different ideas about what infinite sums mean. And they're saying, in some situations it makes sense to define this sum, 1 plus 1 plus 1 plus 1, as being equal to minus a half. We can make that definition, and some things work out.
Yeah.
And in fact, in those exact same situations, 1 plus 2 plus 3, we should define to be what?
Minus
a
1/12.
Minus a 12. So somehow that makes sense, which is pretty surprising, right?
Yep.
And the last thing I want to show you is what Hardy has to say about that, because he's very careful what he says. The formula give examples of what he calls the R summability, but we'll just call it the summability of divergent series of positive terms. We can use such equations as did Euler and Ramanujan, very famous mathematicians. Have you heard of their names?
Yep.
To define the sum of a series such as 1 minus 1 plus 1 minus 1 of the more usual type but the definitions have a narrow range and demand great caution in their application. So what do you think he's saying there?
So you can't use it everywhere.
You can't use it everywhere. And even, he goes through an example down here below, which I'm not going to go through, but he goes through a couple very simple examples where you go astray very quickly if you try to use these definitions. Just doing things that you might think are totally normal, multiplying by 2, adding a couple series together, things seem to fall apart very quickly. So while it is true that in some situations mathematicians can interpret these sums in these ways that seem very strange, right?
Yeah.
You have to be very careful. He says it right here. Hardy says it right here. Great caution.
Great caution.
Great demands great caution. So this is a fascinating field, and it's a fascinating development in mathematics. And these, well, Euler was in the 1800s. Ramanujan, I think anyway. Ramanujan was in the early part of the 1900s. So this sort of stuff is what mathematicians have been coming to understand only really in the last 100 years. About how you can interpret things one way and sometimes another way, but it's very, very interesting. Unfortunately, the 1 plus 1 plus 1 equals minus a half, and the 1 plus 2 plus 3 plus 4 equals minus 1/12 are a little bit more complicated than what I can explain to you guys. But they're fun to think about, right? Mm-hmm. And do they make sense?
Yeah.
Yep.
They do make sense. Okay, well, good. Well, maybe we'll talk about this one more time later on too.
Yeah.
All right.
It's pretty fun.
It is pretty fun. Great work today, guys.